In this chapter, we're going to look at rational expressions. In this lesson, we're going to look at simplifying rationals and non-permissible values. And we're going to start by looking at some definitions.
Okay, hi everybody. So in this video we're going to take a look at clearly rational expressions, and specifically we're going to look at simplifying rational expressions and non-permissible values, determining the non-permissible values. So let's start with this here. What is a rational function? Well, okay, a rational function is any function that can be written in the form n of x over d of x, specifically where d of x cannot equal 0. We're not going to allow that value to equal 0. Now notice that I'm not saying that x can't be 0. X could be 0. As long as the function, the value of the entire expression in the denominator isn't 0, because division by 0 is not defined. Okay? So, anyway, n and d are both going to be functions here of x. Okay? And specifically with what we're looking at here, we're looking at polynomials. And for the time being, we're going to say that d of x, okay, the denominator, has got to have a degree of 1 or higher. Now, that's not necessarily strictly true, but it makes things a little bit easier for us right now if we restrict it like that. So we're going to say that these are rational functions here because you've got a poly over a poly, so the degree 1 over degree 1. Here we've got a degree 0 over a degree 2, and then here we've got a degree 0 over degree 1. But for the time being, we're going to say that this one right here is not a rational function, simply because the denominator here has got a degree of 0. Essentially what we're trying to get at here is this expression right here, for example, could be written more like this. You could distribute that 5 to both of those terms and make that 1/5 x plus 3/5. And the better description of that is it's a polynomial, okay? And so that's what we're going to say. Now, could you argue that this is rational? Yeah, if you really wanted to, you could argue that that's a rational, but a better description of that would be to say that this is a polynomial. It's like the argument here, if I've got a shape, okay, it looks like this, where all sides are the same here. Well, that is a rectangle, but a better description of that would be to call it a square. Okay, that communicates more clearly what's going on. So that's kind of the situation that we're at with this. This, rational, but a better description would be to call that a polynomial. And so that's kind of how we're going to set up our definitions so that that's the conclusion that we come to. So now a non-permissible value, just to be clear here, is going to be a value for which of the variable that causes the expression to be undefined, which means it causes the entire denominator to become 0. So it makes the denominator equal to 0. And since division by 0 is undefined, we call it a non-permissible. Okay? Now, to find the non-permissible values, you're basically going to solve for x in the denominator. We're going to set the denominator equal to 0, solve for x, and away we go. And we always list NPVs before you simplify. Okay? That's important because frequently when we simplify, we're going to lose factors that are common to the numerator and denominator. In fact, there's some special vocabulary associated with factors that we lose and factors that we don't lose. But you want to identify all of the non-permissibles early, because if you don't, you're likely going to miss some that are in there that you simplified away and that you're no longer seeing at the end. So it's always a good idea to identify those non-permissibles before you simplify. Anyway, let's take a look at some examples now.
Okay, so let's take a look at some examples here. And our primary goal right now for this section is just going to be to talk about non-permissible values. Okay? So, for example, right here, find the non-permissible value of that rational x plus 3 divided by x minus 5. Okay? Well, the non-permissible value is going to be 5. Okay? Since replacing x with 5 here, if I replace in the numerator, I'm going to get 5 plus 3, which is 8. Not a problem. But if I replace the x with a 5 in the denominator, I'm going to get 5 minus 5. That's 0, and I don't want a 0 in the denominator. Now, notice that 0 is not an issue here, though. If you plug 0 in for x, you're going to get 0 plus 3, which is 3. 0 minus 5, which is negative 5, and that's okay. Having a result of 3 over negative 5, that's fine. Okay, so please don't make that very, very predictable result and just assume that 0 is automatically a non-permissible when it's not. It has to do with how it affects the value of the denominator. So now let's go through and take a look at some of these. So for example, in this rational right here, 3 over x minus 2, my issue here is I do not want the denominator to go to 0. So what I'm going to do is I'm going to set it equal to 0 to figure out what the problem is. And so when I do that, okay, and actually I'm going to try something here because this bouncing back and forth is a little odd here. Now what I'm going to do is I'm going to bring that 2 over. Okay, so when x is equal to 2, the denominator goes to 0, so therefore my non-permissible here is that x cannot equal 2. And actually in a situation like this, you'd actually call that a pole for the function. You don't even have to worry about that, but another word for it would be to find a pole here. 5 over x, oh, this is a great simple little, okay, hold on a second, I'm going to try this. This is a great simple little rational. The denominator is just x. So this is really straightforward here. I simply can't allow that denominator to equal 0. And this is a situation where, yeah, now x can't be equal to 0 because it is the entire denominator, or it is the factor in the denominator. That can't go to 0 because it causes this to be undefined. Over here, I've got two functions multiplied together, okay, two linear functions here. So I can't allow x plus 2 multiplied by x minus 1 to become equal to 0. So I'm going to figure out where that would happen. Now, if the product of these two is equaling 0, that means one of the two factors must be 0. That's the only way that that's going to work, to have those two multiplied together and become 0. Well, one of them must be the 0. So which one is it? Well, I don't know. It could happen if x is equal to negative 2. If you plug negative 2 into this, the numerator becomes 5. This becomes negative 3, but this becomes 0, which causes the whole denominator to become 0, which causes the whole thing to be undefined. So that's a problem. Or x could equal 1. The numerator becomes 8. This term here becomes 3, but this one goes to 0. And again, that product becomes 0, and then the whole thing becomes undefined. And that's why these are my two non-permissibles. So x here cannot equal negative 2 or 1. Over here, the only thing that makes this particular question a little bit different is that now our denominator here, that linear polynomial, that's got a coefficient in front of the x, so it's a little bit more complicated. But I mean, not by much. So 2x minus 3, I'm going to see what happens when that equals 0, so that 2x is going to equal 3, which means the denominator goes to 0 when x is equal to 3 halves. So that means my restriction here is I cannot allow x to become 3 halves. Now in the numerator, that doesn't cause the problem. The problem is not the numerator. The numerator can go to 0, by the way. That's not an issue at all. It's when the denominator goes to 0 that's the issue. So down here, 2 minus x over 2x multiplied by 6 minus x. And again, we are really just interested in where that denominator goes to 0. So I'm going to set up my equation like that. So either 2x is equaling 0 or 6 minus x is equal to 0. That will occur when x itself is equal to 0. So if you've got x, and I hope you're seeing where this comes from, if you've got x kind of popping out on its own as a factor, that's when the non-permissible includes the 0. Okay, but if it's locked in a binomial, then that's not going to happen. You bring the x over here, and then the issue becomes when x is equal to 6. So up here we'll say that x cannot equal 0 or 6. Over here, now we're going to start to get into the type of question that you would more generally expect to see on an assessment, okay, where the denominator requires a little bit of factoring. So I can't allow x squared minus 16 to equal 0. So I'm going to figure out where that might occur. Now I could do this one of two ways. I could bring the 16 over and square root. So x squared is equal to 16. I could totally do that. But when you do that, you have to remember that when you take the square root of both sides, you've got to remember the plus or minus. And man, that for some people that is just really, really hard to do, to remember that to include that plus or minus. They'll jump immediately to the 4 and think they're done. The other way that you could do this, it would be, or you could simply factor this x minus 4x plus 4, okay, because that's a difference of squares. And then each of these factors has to go to 0. And I'm just going to kind of jump to the answer here. So it's going to be 4 or negative 4. Those are my two restrictions that are going to pop out here. So x cannot equal negative 4 or 4. So I could do it one of two ways. Each has their little issue here. Here you have to remember to plug in the plus or minus, but here you have to remember how to factor. Yeah. So one or the other. Okay. These two right here are going to be very, very similar in how we approach this. So I can't let the product of those two factors become 0, which means I can't allow either one of the two individual factors to become 0. So here, whoops, this is going to be x can't equal 0, so I can see that right away here. Here I got to do a little bit of work. I'm going to bring that x over. And I see that if x is equal to 3, that will make the denominator equal to 0. And I don't want that, so add 3 to my list of restrictions. Now, notice that I didn't do anything with the numerator. I didn't factor it. Okay, that's because the non-permissibles are really coming from terms that end up in the denominator. Now, notice I said end up in the denominator and not are in the denominator. And the reason why I say that is because there are certain operations that we're going to look at later on, and you can think of one right now, maybe division, where you multiply by the reciprocal, and what ends up in the denominator might change as you move through a problem. And that creates other non-permissibles that you got to worry about. But for right now, with the questions we're working on right now, not really all that interested in what's going on with the numerator. I will be when we start to simplify them. So here, 3x minus 1 multiplied by 2 minus x. Curious to know what values of x make that equal to 0. Okay, but that means either one of those two factors could be 0. So bring the 1 over. Here I'll bring the x over. And in this case right here, I'm already done because x is isolated. But here I'd have to go one step further. Divide by 3. And so my restrictions are here that x cannot equal 1/3 or 2. Here, just like the one right above it, I got to do a little bit of factoring to make that work. So 3x squared plus 4x. I'm going to see what happens to make that equal to 0. In this case, there's really not a lot of factoring to go on to happen there. Just a common factor of x that I'm going to pull out. And so now, if the product of those two, okay, that x by itself and the 3x plus 4, if that is equal to 0, then again, one of the two factors must be 0, and that x equals 0 is all kind of done there. So bring over the 4, and then I'll divide by 3 to get that x isolated. So I can see right here, x cannot equal negative 4/3 or 0. And now finally over here, and the question here, J, is a little bit different than the ones before because now I've got this other variable in here. But I still approach it the same way. Don't let that stop you. Don't let that confuse you here. Just kind of plow ahead because basically look what's going on here. I've got two factors multiplied together. Well, hey, just like in the previous questions, I got to figure out, hey, what values of these variables make this equal to 0? And I've got two functions here multiplied together to get 0, so that means either that x is equal to 0 or that y squared is equal to 0. Either way, that will make the denominator equal to 0. Well, immediately here, that spits out a restriction. Here I got to go one other step here. I'm going to take the square root of both sides. Now, the square root of 0 is 0. Now, I often bump into students who will say, no, you can't take the square root of 0, and then you think about it a little bit, and okay, no, wait a minute, yeah, you can. Okay, 0 multiplied by 0 is 0. The difference here, as opposed to what we did up here, when you take the square root of 0 here, you don't need to really worry about plus or minus because 0 isn't like that. 0 isn't a positive number or a negative number. It's that boundary in between those two regions on the number line. So my answers here are going to be x can't be equal to 0, and at the same time, y can't be equal to 0. Okay, and those are our non-permissibles. Okay, now let's take a look at simplifying rational expressions here. So what we're going to do here to start off with is we're going to factor the numerator and the denominator. okay? Because you're going to cancel factors, okay? That's the whole goal here. Okay, we are going to cancel factors. That's how we do the simplifying. So if it's not written in factored form, then you really can't do this, okay? Then we're going to identify the non-permissible values, because we want to do that before we ultimately simplify the expression here. Then we're going to simplify if possible. And what we mean by that, by simplifying here, is we are going to identify ones. Okay? We're going to identify the ones in the problem here. Because remember, 3 divided by 3 is 1. 10 divided by 10 is 1. X divided by x is going to be 1 so long as x isn't equal to 0. And that is going to be dealt with here when we deal with the non-permissible values. So here's what this might look like. So the following expressions are equivalent expressions, and we're going to simplify here. So 3xy divided by 5xz, the x's are going to simplify. They're going to become 1. Okay? So x divided by x is equivalent to 1. And if you multiply what's left here by that 1, then you're going to get that 3y over 5z. And that's true so long as we state that x can't be equal to 0. And that, again, that would have been handled up at that step right there. Here, in this one, you've got 4a squared b cubed over negative 3ab. Well, remember what the exponents mean here. This means that I have 2 factors of a up at the top here and 3 factors of b. Well, one of those factors of a divided by this factor of a is going to become a 1. One of the factors of b here is going to cancel with this b. And when I say cancel, what I mean is form a factor of 1. That's like exactly what I'm intending by that. So I'm going to end up with 1 times 1. And then what you're going to be left with here is going to be 4 times a times b squared over negative 3. And that's what we have written here on the right-hand side. Now, the same thing happens even if you're looking at binomials. Okay? And, I mean, that should make perfect sense here. I don't know what x is, so I don't know what x minus 2 is. But I know that whatever this is, x minus 2, is going to be the exact same as this one right here. So even though I don't know what value x is, I know that x minus 2 and x minus 2 are going to be the same thing, and so they're going to cancel or become 1 as long as we identify what the non-permissible value is. And so those are going to disappear, and we're going to be left with x multiplied by x plus 3 over y multiplied by x plus 5, all multiplied by 1. But that multiplication by 1 isn't necessary. I don't need to write that in there. Now, what you can't do is this, and this is, man, these are really, really popular mistakes that people make here. The first two here that you're seeing, this deals with just canceling. People are canceling the 3's, people cancel the x's here, but you can't do that because 3 here is not a factor. It's not a factor. When you add it to x here, this becomes what we call an addend, but it's not a factor. Okay? Factors are multiplied together. That isn't. Now, the funny thing is here, people wouldn't do this if we put numbers in there. If this had been, for example, 2 plus 3 over 3, people are far less likely to cancel the 3's. They know that this is going to become 5 over 3. But when you have that variable in there, immediately there's this tendency to want to cancel. Same thing here, okay? But you can't do that. And this is the exact same thing. X, in both cases here, numerator and denominator, x isn't a factor. Okay, it's part of a polynomial. Now, other things to consider here is if you've got x minus 3 divided by 3 minus x, those are exact opposites of each other in the sense that the signs on the terms are the exact opposite when you compare numerator and denominator. And what that means is when you divide that out, you're actually going to get negative 1 instead of positive 1. Now, what I would tend to do with this is I would approach this a little bit differently. And I'm going to suggest an approach that you might carry on kind of throughout and think about it as you do your algebra here. There's something about this particular expression right here that isn't pretty. Okay? This denominator here I don't really like because I don't like the fact that the x is showing up at the back here. So normally what I would tend to do with a problem like this is I would want to make it look pretty. So I'm going to move the x up front. And I can do that, okay, because remember, when I see 3 minus x, I can, in my head, interpret that as 3 plus negative x. Those are going to be equivalent. I can do that. And order doesn't matter when I do this with addition. So I can move that minus x plus 3 up front here. And then what I would do is factor out that negative. Okay, pull out a factor of negative 1. And when you do that to those two terms, what you do is you change the sign on both of those, and so this becomes x minus 3. And now I've got this x minus 3 can cancel with that x minus 3 in the denominator. It becomes the 1, remember? So, and that 1, sorry, when you do the canceling, I didn't really say this before, but that 1 is usually interpreted as going in the numerator. Okay. But there's still a negative 1 in the denominator, and 1 divided by negative 1 is negative 1. And I'm just doing that to give you another way of approaching it that might, it's a little bit slower, but it might make a little bit more sense to think of it this way. And you do this a few times, then you're going to get comfortable enough that you can just jump from there to there and you won't have a problem. Same sort of a thing with this one. These are identical to each other, really, because remember, order doesn't matter for addition, but you still might want to make it look pretty first by just changing the order of the denominator, and then I can clearly see that those are identical to each other, and I'm going to get a 1. Anyway, so that all said, let's take a look at some examples. Okay, so now here's our set of examples here, and what we're going to do is we're going to write an equivalent expression, we're going to simplify, and we're going to list the NPVs. So now, thinking back to our steps here, what we wanted to do first is we want to factor the numerator and the denominator. Now, in this first question here, I take a look at this, and I've got 18 multiplied by x to the 6th. And remember what that means is that I've got 6 factors of x multiplied out there. Down in the denominator, I've got 3 multiplied by x cubed, and that means I've got 3 factors of x multiplied out there. That is actually in factored form. Okay? This is just a shorthand way of writing that set of factors there. So now what I want to do here is I want to identify the non-permissible values. Well, the denominator can't go to 0. I can't let that happen, and the only way that could happen is if x is equal to 0. So I can't let that happen. X can't equal to 0. Now, this is going to be equivalent to, well, what? Well, let's find the ones. Now, I'm going to find the ones here because 18 is like 6 times 3, and then the 3's will cancel. So 18, and basically it becomes 18 divided by 3 is just going to be 6. You can look at that a couple of different ways, but that's ultimately what it is here. Same thing with this one. X to the 6th divided by x cubed. Well, now remember, if I'm dealing with 2 powers here and the bases are the same, I simply subtract the exponents. Or think of it like this. I've got 6 x's in the numerator, 3 x's in the denominator. Each pair, numerator and denominator, is going to become a factor of 1. Well, that's just going to leave me with 3 in the numerator, so 6x cubed. Over here, negative 22a cubed multiplied by b squared. That is in factored form. 11a cubed b, that is in factored form. So now I look at the denominators here and I'm looking at my individual factors. Well, I can't allow a to go to 0. 0 cubed would just be 0. That would be a problem. I also can't let b go to 0 because I've got that factor of b here. So now I'm going to look at simplifying, and because of the fact that it's factor the numerator, factor the denominator, I'm just going to do the division. Negative 22 divided by 11 is going to be negative 2. A cubed divided by a cubed, well, I like that because that's going to create a 1. So there's going to be a factor of 1 here. Now, I could write a factor of 1 there in parentheses, but I don't need to because I know that that's not going to change anything. Here in the numerator, I've got 2 factors of b and 1 factor of b in the denominator. So one pair there, numerator and denominator, is going to become a 1. And I'm going to be left with a factor of b in the numerator. Or just look at it like b squared over b, subtract the exponents. You're going to get b to the 1 there. Over in this next question. Again, quick glance tells me that it is already in factored form. Okay? So now I'm just going to look at the denominator. I've got this factor of m by itself here, so I know m can't equal 0. And then I've got this n to the 7th, just move this over, n to the 7th here, 7 factors of n. Well, none of those can be equal to 0, so I have to include here also that n can't equal 0. Now, when you take a look at that first row, it is very tempting to want to think that, well, my gosh, look at the pattern here. I can never allow the variable to be equal to 0, but that would be an improper assumption here. It's only because these 3 examples have been written in this already factored form and the variables themselves are popping out as individual factors. Now here, when I simplify this, 15 and 8 don't share any common factors, so that's actually not going to get any better than that. Now here, m to the 4th over m, when I subtract the exponents there, that's going to be 4 minus 1. That's going to be m cubed. The n's is a little bit different. I've got 6 factors of n in the numerator, but 7 factors of n in the denominator. If I take out pairs and cancel them all as I go, I'm going to be left with an extra one in the denominator. Another way to think about that is 6 minus 7 is negative 1, and n to the negative 1 was going to move that down to the denominator. So n to the positive 1 in the denominator. Now, let's take a look at this next one. 3x multiplied by 4 minus x over 12 times x minus 4. Now, this is already in factored form. So my first thing is going to look at the denominator and see if I can come up with a non-permissible here. Well, 12 is not the problem. It's going to be the one with the variable in it. So x minus 4, I can't allow that to go to 0. Now, if I plug 0 in for x, that's not going to cause a problem because that'll just become negative 4. And I don't really care about negative 4. But I can't allow x to be equal to positive 4 because if x equals positive 4, that denominator is going to become 0, that factor. Then the whole denominator will become 0. Now, right now, I don't particularly like the way the numerator looks. It's in the wrong order. So I'm going to make that pretty by changing the order that those two terms show up in. Now, those don't immediately match, but I can make them match by factoring out that negative. And that just changes the signs, okay, on every term in that binomial, or both terms in that binomial. And now, x minus 4, that will become a 1, so long as x doesn't equal 4. And I've already addressed that, so I'm okay. Now, negative 3x over 12, well, 12 and 3 each have a factor of 3 that's in common, and when I divide that out, I end up with a 4 in the denominator. So this is going to be equivalent to negative x over 4, so long as x doesn't equal 4. Now, bear in mind, when I look at this right here, okay, well, this doesn't have a problem if I put 4 in. If I put x is equal to 4 in here, that just goes to negative 1. What's the problem? It's not the simplified form that has the problem. It was the original problem, the original question that had that problem. Okay, and that's why for these to be equivalent, okay, for this expression to be equal to this expression right here, they're not until I include that restriction. And that's why that's important here, because I don't see that problem when I look at the final answer. Now, over here, we look at this one. Okay, again, it already is in factored form. Okay, now the factor down here, I don't like how that looks, so I'm going to actually change that a little bit. Because it's just addition, though, it doesn't take me much to change that. I just got to change the order. That looks way better, and I haven't done anything I'm not allowed to do here. When I take a look at those factors in the denominator, 6 isn't the problem, but this a being squared is. And I can't let a go to 0 because 0 squared is going to be 0, and that'll cause the whole thing to go to 0. But I also can't let this term go to 0 here. Now, if I set that equal to 0, remember, I'm going to bring the 5 over. It'll become negative 5, and then I'm going to divide by 2. So a can also not equal negative 5 over 2. And the more comfortable you get with solving, the easier that gets here. So, okay, the 2a plus 5s are going to cancel. They're going to become 1, a factor of 1. 6 divided by 6 is going to become a factor of 1. A squared divided by a squared is going to become 1. Everything becomes 1. So this is going to be equivalent to 1, so long as you include these restrictions. Whoops. Oh, shoot. Actually, I wrote it up here, too. Sorry, that was supposed to be 2. I don't know why I did that. That's supposed to be 2. That's supposed to be 2. Now, this answer might look a little bit weird here because the answer is 1, so long as a doesn't equal 0 and a doesn't equal negative 5 halves. Well, what a? There is no a down there. Yes, that's right. That was an issue that was up here, and it carries through the entire problem. So even when I have to express this simplified answer, in order for these to be equivalent, I have to include those restrictions that are popping up right there. Now this last one here, once again, I see a little bit of an issue here. Now it's not quite factored yet, okay, because I can see in the denominator there's a common factor of 3, but I'm not there yet because I don't like the fact that they've pushed that c to the back. So I'm going to move it to the front. Okay, and again, I can do that as long as I move that negative with it. And now, I'm going to pull that negative out, but I'm also going to pull out that 3, because the 3 is common. So it'll be negative 3 multiplied by c minus 2. Okay, well now I can look at the denominator and say, okay, I know that c cannot be equal to 2. And I also can see that c minus 2 over c minus 2 is going to become a 1. So my final answer here, and I watch people do this incorrectly frequently, where they'll get right to this pot right here, then all of a sudden they'll write negative 3. But negative 3, whoops, sorry, I just got a, negative 3 is not the answer because that negative 3 was in the denominator. That's 1 over negative 3. Okay, that negative 3 doesn't automatically jump up to the numerator simply because I canceled here, right? This c minus 2 over c minus 2 becomes a 1. A 1 multiplied by, well, 1 over negative 3. So here's what it's equal to as long as c does not equal positive 2. And that answer is equivalent to that original expression. Okay, so just for a quick moment here, we're gonna transition over and we're going to look at slightly more complicated questions here, but the steps remain the same. We want you to factor, state the non-permissibles, and then we want you to reduce by once again finding the ones. The ones, I don't know if you're supposed to have an apostrophe there or not. I looked at it before and I questioned that. So anyway, I did it once without, did it once with, whatever. So we're going to factor, state the non-permissibles, and then we're going to find the ones here as we reduce. So for example, you're going to look at a problem like this, and what we're going to do is we're going to write this in an equivalent form where we factor this. I recognize that the numerator is a difference of squares. Okay, and the denominator isn't, but the denominator can be simplified fairly straightforward. I'm just looking for factors of negative 6 that combine to get us negative 1, and that's going to be minus 3 plus 2. Whoa, I have an extra x in there, I don't know why. X plus 2. Now, this is going to be equal to, I know that the x minus 3 is going to become a 1. And I can cancel that so long as x does not equal 3. Okay, and so this is going to be equal to x plus 3 over x plus 2. Now, you might look at this and say, well, wait a minute, that's fine, but shouldn't you have said that x can't equal negative 2 because that is also another restriction? And the answer is, sort of. I actually don't need to state it because I can see it right there. I can totally see it right there. But the fact that x can't equal 3, that is no longer clear to me from the problem. It just isn't. I can't tell that 3 is an issue by looking at this problem, but I can tell that negative 2 is. So I don't really need to state it. Now, however, okay, where I teach here, the expectation is that you will write that down, and in fact, we would dock you if you didn't. Okay, just being honest with you, we would address that if you hadn't here. Make sure that you are stating all of the non-permissibles. So, oddly enough, just to give you a little bit more information here, when you see it down there, after you've simplified, if you've still got a non-permissible in there, we call that a pole. Okay, the pole of that function. This one here is a removable discontinuity. This one's here is a pole. I'm just getting all nerdy on you here, but just something to think about there. Here, this next one here, I'm going to let you know right now, I don't like the fact that that negative x squared is showing up at the back there, so I'm going to change positions of it. 2x squared minus 9x plus 4. And then I don't like that it's starting with a negative, so I'm going to factor that negative out. This becomes x squared minus 16. Now, that looks way better to me, and as soon as it looks better to me, it turns out that's even easier to work with. So now, this is a difference of squares. That'll be x minus 4, x plus 4. The denominator here, I can factor that. I can break that apart. That's just going to be 2x and x. And now I'm looking for factors of 4 that I can put here. Well, I could put 2 and 2, but if I put 2 and 2 here, I'd be saying that there's a common factor of 2 somewhere in this original problem because there's a common factor of 2 here, so I don't really want to do that. So I don't really want to split that 4 up into 2 and 2. What I want to do is split it up into 1 and 4, and it looks like I'm going to have to put the 4 over here so that I don't create a common factor that isn't in the problem. Now, 2 times 4 is going to be 8. 1 times x is going to be 1. I can get a 9 out of that when I add them together, but I do need it to be negative, so I need both of these to be negative here. Okay, so now I know that the x minus 4, those are going to become 1. That is going to leave me with negative x plus 4 over 2x minus 1. But I have to state the non-permissible. I have to state that x cannot equal 4. If I plug 4 into that, that's going to make that 0 over 0. That doesn't work. That is what I need to do. But I need to identify this pole as well to make sure I get the marks there. So I'm going to bring the 1 over, divide by 2. So the additional one here is that x cannot equal a half. And so this is the sort of questions that we're going to do a little bit more of. So factoring, okay, maybe making it look a little bit prettier before we get into the simplifying there, identifying the non-permissibles, and identifying all of them. Okay, we might even go up here and state all of them. It's not mathematically necessary, but in this particular case right here, we're trying to make sure that you are recognizing all of the non-permissibles. Okay, so let's take a look at some examples here. It says write an equivalent expression and simplify and list the NPVs. Okay, so let's just take a quick look here. Now, what I want to do here is I want to cancel factors, but notice that this isn't in factored form. The numerator isn't in factored form. I've got 2 terms added together here, so what I need to do is I need to first put it in factored form. And I notice that there's a common factor of 5 to the numerator, so I'm going to take out a 5, and that's going to leave me with 5r squared plus 2 all over 25r squared. And the only thing here that's going to cancel or simplify here is going to be that extra factor of 5 there. So this is going to become 5r squared plus 2 over, and then the 25 and the 5 and the 25 here have a common factor of 5, and those will become 1. So we'll be left with 5r squared. All I've got in the denominator that could possibly become equal to 0 is that r, and so I simply cannot allow that r to go to 0. And so there we go. Again, notice that 5r squared, those cannot cancel. Okay, if you were to plug a number in for r and evaluate it, let's say you put in, let's say 1, for example. If you plugged 1 in for r, 1 squared is 1 times 5 is 5 plus 2 is 7. It's 7 and 5 because the denominator here would become 5, and that doesn't cancel. So that's as good as it's going to get. Up here for this one, same thing. We want to do some factoring first so that we can cancel some factors. Now in the numerator here, with the 18 and the 30, there is a common factor of 6. Okay, and when I look at the x factors here, I've got 2 factors of x here, 3 here, so the common one would be 2. And when I pull out the 6x squared, I'm going to be left with 3x minus 5 over 24x squared. Okay, well, I can now cancel factors. There's a factor of 6 common to the numerator and denominator, so that's going to disappear. And then I've got the common x squareds there, and they're going to completely disappear. So I will be left with 3x minus 5 in the numerator over, and then I'm just going to be left with a factor of 4 in the denominator. Now, this part of the expression doesn't have a non-permissible, okay? There is no variable in the denominator to make the denominator go to 0, so I don't even have to worry about that. So I'm just going to fix this here. Whoops, that didn't do it. There we go. And but previously we lost the x squared there. The x was not allowed to go to 0. Okay, up here the x couldn't go to 0, and now that it's gone, that x can still not go to 0 in order to make these expressions the same. Now this one over here is going to be a little bit more interesting to factor because there's a little bit more to the factoring. The numerator is a difference of squares, so x minus 5 multiplied by x plus 5. And our denominator simply has a common factor of 3. Okay, well, x minus 5 divided by x minus 5 will become 1, and I'm going to be left with x plus 5 over 3. Now, but I can only cancel the x minus 5 with the x minus 5 as long as I state that x cannot equal positive 5, because if x does, then I get 0 over 0, and that's undefined, and I don't want that to happen. So there you go. Now let's take a look at the next one here. M squared minus 9 over m plus 3 squared. Well, again, in the numerator we've got this difference of squares that we can factor. And then the denominator's got this m plus 3 squared. In other words, we've got that factor repeated. So one of the m plus 3's is going to cancel with one of them, okay, or become 1, I should say. Remember, when we say cancel, we typically mean that that's going to become a 1. And then this will become m minus 3 over m plus 3. Now, I did some canceling there, and the factor m plus 3 divided by m plus 3, remember, I can't let that go to 0, which means I cannot let m become, well, it's got to be negative 3. I want it to be the opposite sign of the value that I'm seeing there, so that if I plug the negative 3 in, plus 3 creates a 0 there, and I don't want that to happen. Next one. Next one I got to look at a little bit. It's not a difference of squares, but I do have a common x squared there, which is going to leave me with an x minus 1. And then in the denominator, I'm going to have a common x squared as well, but that's going to leave me with an x plus 1. So the x squared divided by x squared, that's going to become 1. And so I'll be left with x minus 1 over x plus 1. Except when I cancel that x squared over x squared, that's with the stipulation here that x cannot be allowed to equal 0. Now, and I know I've said this before, technically speaking, I'm okay with that. I can stop right there because I can see the other restriction sitting right here. However, the expectation is going to be that you are going to identify that in your list of non-permissible values. So that x plus 1 there does create this other restriction. I can't let x go to negative 1. With this one right here, I see that the numerator is a difference of squares, so I'm going to make that x minus 6, x plus 6. And what I'm not completely thrilled with, I don't like the fact that this is written backward. So I'm going to move that around. I'm going to keep the negative with the x. I can do that. Okay, I can do that. And then I'm going to factor that negative out. So it's going to be x minus 6, x plus 6 in the numerator, divided by negative x minus 6 down there in the denominator. I like that way better. That is much cleaner in my mind here. So now I can cancel that x minus 6. And actually everything in the denominator canceled there, so it became a 1, so that there is no denominator now. So this is just going to be negative. Okay, that negative will move up. X plus 6. I mean, and here's a really good example of what I was trying to talk about before here. Notice that x plus 6 doesn't have a non-permissible. There is no denominator to go to 0 here. But the expression did have a denominator. So at one point, we could not allow x to become positive 6. And in order for this to maintain its equality all the way down, step by step, I need to state that. Even though that particular restriction has visually disappeared, it has not disappeared in the problem, and so I need to be explicit about that that restriction there. Here in this problem in G, well, this is kind of wonderful. It's already been factored for us. I mean, I'm just going to cancel stuff that I see here. I know that m minus 2 is going to cancel numerator denominator. 14 and 21 each have a common factor of 7, so that's going to leave me with a 2 in the numerator and a 3 in the denominator. And then I've got 7m factors in the numerator and 4m factors in the denominator. Well, that's going to leave me with 3 of them in the numerator. So what I'm going to be left with here is going to be 2m cubed. Now the m minus 2's disappear all over 3. Well, that simplified down wonderfully. But I lost a couple of things. I lost the m minus 2, which means there was a restriction that m could not equal 2 that existed in the problem. Additionally, m showed up by itself as a factor, which means that m can't equal 0 as well. Okay, I want to make sure that I address both of those. So now remember, actually let's just glance up through the questions that we've done thus far. Notice that 0 does show up frequently, but not all the time. And the only time that I really want to use 0 as a restriction here is when you see the variable show up in the denominator by itself. That's when you want to pay attention. Let's try this one here. It's going to require a little bit more factoring because that numerator, once again, is a difference of squares. Now, I don't like the fact that that negative, or sorry, the x is at the back of this expression. I want it up at the front. But I'm actually going to do a couple of things here because there's a common factor of 2 here. But I'm going to make it a negative 2. I'm going to take out a negative 2 here. That's going to change the sign on this term and make that a positive 5. And then it'll be minus 1 there. Okay? So in the one step there, I'm going to do the factoring, but I'm also going to change the position of those terms. And now the 5x minus 1 cancels, becomes a 1. And I'm going to be left with a negative, that negative, I'm just going to write it up front here, 5x plus 1 over 2. But I lost a 5x minus 1 from the denominator, which means there is a restriction on the x. Now, this is a little bit more complicated of a binomial than we've done in the previous questions in this section. So remember, you're going to bring the 1 over and then divide by 5. So it's going to be x cannot equal 1/5. Okay. Now this last one looks a little bit uglier than the rest of them, but actually I don't think it really is. Notice that there's a common factor up in the numerator of 7x squared. Okay, and if I take 7x squared out, I'm going to be left with x squared. What is that? Minus 5 in the numerator. Ooh, that's close, but that's not quite a difference of squares, so I'm going to stop right there. I mean, I could go further by splitting that into the square root of 5 and the square root of 5. I don't want to do that. That's just needlessly complicated. Down here, looks like there's a common factor of, again, this time 7x cubed. And that's going to leave me with 2 plus 3x. Okay, now, the 7x squared is going to cancel with the 7x cubed here. Basically, the 7's are going to go away. They become 1. And then that x squared over the x squared, the 2x's down in the denominator are going to cancel, but I'm going to be left with an additional x down here because there's 3 factors of x in the denominator and 2 in the numerator. So in the numerator, I'm going to be left with x squared minus 5. The denominator is going to have an x in it. And then I'm going to flip the order of these around because I prefer to have the higher degree term first. Okay, now there's nothing else that really can cancel. Remember that I can only cancel factors, and even though x is a factor of the denominator here, x is not a factor of the numerator. It's part of it, but it's not a factor in the numerator. Now, what values can x not be? Well, x can clearly not be 0 because it does show up as by itself as a factor in the denominator. Here, if I bring that 2 over and then divide by 3, I'm going to get negative 2 over 3, so negative 2/3. And there's my other restriction. There are no others at this point. Okay, there you go. Okay, now we're just going to run through a handful of quick problems here, just to give you an idea of another way these questions could be asked and the sort of things you want to think about here. So are the following expressions equivalent? Okay, are these expressions right here the same? Well, if they are, then what that means is there's a common multiple to the numerator and denominator to transition one to the other here. Okay, so just think of it like this. If you've got, let's say, 3/5, if I multiply the numerator and denominator here by 2, okay, then I'm going to get 6/10 here. But we know that 6/10 and 3/5 are going to be equivalent expressions. Okay, that multiple of 2, as long as it's the numerator and denominator, okay, doesn't change the fraction, even though it changes how it looks. So the other way around that would be then to go like this. Well, let's say 6/10 here. Well, I know that there's a common factor of 2 in the numerator and the denominator here, so the 2's will cancel. And if they're equivalent, then I should be able to simplify the one into the other, and that's really what we want to do here. So when I look at this second expression here, it looks to me like there's a little bit more going on. This one has got a numerator that's just 5. This is a little bit more complicated. It looks to me like this one here might have a factor of -3 up there, multiplied by 5. So we're going to take that out here. Now, I'm hoping that if I take a -3 out of the denominator, now because think, -3 over -3 is going to cancel and become 1. I'm hoping that if I do that, what I'm going to be left with is this 2x minus 1, so that they are the same. So if I factor a -3 out of that -6x, I am going to get 2x. And divide that 3 by the -3, and I do get -1. And notice I'm flipped the order here because I prefer it in this order, and it lines up nicely with this one. So what that means is the -3's cancel, and this is equal to 5 over 2x minus 1. Are they equivalent? Yes. It's the same thing. Okay, and notice that there's no other factor of x introduced, so there's even the non-permissibles are the same. From one expression to the other. In this case, it's going to be x can't equal a half, x can't equal a half. Okay, now in this problem, and you're going to see the connection to the previous question we just did, it says, give an equivalent expression to the one that we've got right here where the non-permissible values are plus or minus 1. Now, to create an equivalent expression, that's pretty straightforward. All I need to do is multiply the same thing by the numerator and the denominator. Now, but we want the non-permissible values here to be plus or minus 1. Now, when I take a look at this one right here, I'm going to get a non-permissible value of positive 1. Okay? If I plug positive 1 in for x here, 1 minus 1 is 0. I can't divide by 0. That's undefined. So that one is there. What I need to do is introduce the other one. I need to introduce the I need to introduce the non-permissible value of -1. Well, that means that what I want to do here, to get a non-permissible value of -1, what I need to introduce down here is a binomial that's x plus 1. Okay? X plus 1, because if I plug -1 into here, that creates a 0. Now, I can't just multiply the denominator by x plus 1. Okay? This needs to be balanced, numerator and denominator. So I need to do this to the numerator as well. And now, x plus 1 divided by x plus 1 is 1, and multiplying this expression by 1 doesn't change it. So these are equivalent expressions. And now, equivalent, they're not exactly equal to each other because this one right here does not have the non-permissible of -1, but this one does. But that's okay, that's what we're looking for right here. And so now what we might do here is expand that. This sort of question sort of feels like it wants us to expand it. And notice this is just, these are conjugates, so you're going to get x squared minus 1. And so yeah, this expression right here is going to be equivalent to this one up here, except it is going to have an additional non-permissible value at -1. Okay, this next question is actually a really good question. it's going to require you to think a fair bit about what's going on here. It says when the expression, and we got x squared minus bx minus 14 divided by x squared minus x minus 6 is simplified, we get it to this form right here. Okay? And the non-permissibles are going to be 3 and negative 2. Now when I take a quick look at this, I can see x minus 3 in the denominator here. I can see the non-permissible value of 3. That one's clear to me. What's not clear to me is that negative 2. So what that suggests to me is that the factor that produces that particular non-permissible has been canceled out. It was common to the numerator and denominator. So now I got to think, well, what factor would produce a non-permissible at negative 2? And the answer is going to be x plus 2. So what I know is that x squared minus bx minus 14 over x squared minus x minus 6 is supposed to be equivalent to x minus a over x minus 3. They are not actually equal to each other, so I'm using actually the wrong symbol here. However, if I multiply this now by x plus 2, and I do this in the numerator and the denominator, well, now they're equal because now all I've done is multiplied by 1. So that actually hasn't changed really anything here. But what I have done is introduced that second non-permissible that wasn't clear to us in the simplified form. Now, this question is asking, what are the values of a and b? Okay? Well, to figure that out, what I got to do is I got to expand. Now, just to make sure that I've done this correctly, let's expand the denominator, and I'm going to get x squared. That's going to be plus 2x minus 3x minus 6. Okay, and so when I put that together, that's going to be x squared minus x minus 6. And you know what? That is exactly what we started with. That's a good sign. Okay, that means that what I've created here is correct. So now what I got to do is direct my attention to the numerator here. When I expand that out, I'm going to get x squared plus 2x minus ax, and that's going to be minus 2a. Okay, so it's going to be x squared. I can factor an x out of those two middle terms here. That's going to be plus x multiplied by 2 minus a minus 2a. Now that might come across as a little confusing here, but actually it's not so bad because look at this. The constant over here is negative 14. The constant over here is negative 2 times a. Well, those will only be equal to each other if a is 7. Okay, that negative 14 is supposed to be equal to my negative 2a. Well, that means that a is 7. Okay, that's great. Now, if a is 7, and I plug a into here, okay, if a is 7, that's going to be 2 minus a. 2 minus a, and I know, by the way, when I compare these two, that 2 minus a is going to be the same as negative b. This means that 2 minus 7 is going to be negative b. Well, 2 minus 7 is going to be negative 5. Bring that negative back over, and I get that b is equal to 5. Okay, I like that question. There's a lot going on. I like this, the way the question forces you to compare those terms. Okay, I'm comparing the linear term, I'm comparing the constant term to figure out what the value of the variables are. That's a great question, a great skill to have. Okay, and our last question here says an equivalent expression to 3x squared over 2x squared minus x can be expressed in the form ax to the b over 4x cubed minus cx squared. So the values of a, b, and c respectively are. Okay, so we're doing something similar to that we did in the previous question, where what we're going to do is we got to compare the two expressions that we've got and figure out what these pieces are. Now, the way we're going to do that, though, is we're going to kind of focus our attention on the one term that we have complete information on. We know that we're going from 2x squared, and 2x squared is jumping over and becoming 4x cubed. Now, I know that that's what's going on here because the other expression here is cx squared, but I don't want to set those equal to each other because then I'm left wondering, well, what happened to this negative x? Okay, so turning 2x squared into cx squared is just a matter of multiplying by a constant. But to turn x into an x cubed means multiplying it by a quadratic, and so those aren't the same. So what I'm going to do here is compare highest term to highest term here. Now just think about what did you multiply by? And by the way, let's take and write this one out here. 3x squared over 2x squared minus x. Okay. What do I have to multiply by 2x squared to turn it into 4x cubed? Well, to take 2 and convert it into 4, that's simply multiplying that by 2. That's straightforward. And then to turn x squared into x cubed simply means I need to include another x. So that's what I have to do to the denominator. What does that do to the numerator? Well, I have to do the same thing to the numerator to balance that out here. Now, notice that by doing this, okay, I could possibly be creating a new non-permissible. Now, it turns out I'm not, because even in the original, I had a non-permissible value that was just 0, because I can pull out the x by itself. So I didn't, but there was the possibility of that. When you multiply those together, you're going to get 6x cubed in the numerator. And then when you distribute that through, you're going to get 4x cubed. And I knew that was going to happen. We chose that factor specifically to get that 4x cubed out of there. And then when I multiply that here, I'm going to get negative 2x squared. So now comparing these, I see that A is going to be 6, B must be 3, and C must be 2.